Hello. In this lesson we're going to look at the properties that we have for multiplying a vector by a scalar. Considering any two vectors u and v and a scalar k and m, which are real numbers. Then if we have the expression k times u plus v, the sum of those two vectors, then we can expand this as k times u plus k times v. So that scalar is going to multiply each individual vector from that sum. And this is the distributive property. Also, if you have k times m times u, this is equivalent to k times m, everything times u. So those two scalars become a factor for this vector u. This is the associative property. And then we have the identity property, just like before, but when multiplying by a scalar is going to be 1 times a vector u is going to be the vector u. So that scalar 1 is not going to change our vector. Again, for any vectors u and v and the scalar s and t, two real numbers, the following expression su plus tv, it's called a linear combination, right? So you have scalar multiples of those vectors. So just in case you are encountering this terminology, you should be familiar with what it represents. The resultant of a vector u times a scalar k is going to be, if k is a positive number, you're going to have the same direction for the resultant vector, only that the magnitude is going to be multiplied by that k value. So if you have 2 times u, it's going to be a double in size, but the same direction. So this k can be any real number. Therefore, if the k value is a negative number, the resultant vector of multiplying your vector u, the initial vector that you started with, is going to be of an opposite direction. So just so you are aware, when the scalar is negative, the resultant vector is going to be of opposite direction than your initial vector. And of course, the magnitude, it's again multiplied by that particular scalar. It doesn't matter what value you have for k, the resultant vector is collinear. It's the same direction or opposite, it's still collinear with the initial vector. And that's actually a very important property that you should know. Let's also learn about collinear vectors, which are very important. What collinear means is on the same line, associated to something that you already know. For example, co-worker. What does that mean? People that work in the same place. So worker, co-worker meaning in the same place. So linear referring to a line, collinear meaning on the same line. So if I have vectors that are collinears, meaning two vectors that you can find them on the same line. We have actually 3 statements here that are equivalent, and you should know because they help you tremendously. Let's take u and v, two non-zero vectors. Non-zero because for zero vectors we don't really talk about vectors anymore, right? A first statement would be u and v are scalar multiples of each other or in other words we can say u equals to kv, where k is a real number. Then another statement that we can say is that u and v are collinear. Or the last statement we can use is u and v are parallel. So either one of these 3 statements is equivalent to the others. So if these two vectors are scalar multiples of each other, they are collinear, they are parallel, or if u and v are parallel vectors, they are multiple of each other, and they are collinear, and so forth. So it's very important that you know what the relation is between collinear vectors and what they represent. If that is clear, I'm going to conclude this lesson here. Thanks for watching.